Welcome to This is Concrete, a podcast where we speak with the people whose work revolves around concrete and coatings. Let's get to what you came for.
Hello, this is Chad Gill, and I am the host of the This is Concrete podcast. This episode is brought to you by Concrete. Concrete is an experienced custom concrete polishing and coatings company that specializes in transforming plain concrete surfaces into clear, distinctive, and enduring masterpieces. We have been serving both industrial and residential markets for over 2 decades, helping designers, architects, tradesmen, and anybody else bring their designs to life. Also, we are sponsored by Laminate Coaching. If you're looking for an expert guidance on remote staffing for your business, look no further than Laminate Coach. With our help, we can help you streamline the hiring, onboarding, and training of assistants for roles like executive assistants, estimating, and project admins, all within the construction industry. We can even assist with setting up a CRM and a project management tools and support those for you. So don't settle for a one-size-fits-all solution. We customize everything to the unique needs of your business, and you can contact us today at laminatecoach.com. Okay, I want to introduce today's guest. His name is Jim Schneider. He is the executive director of the PCI Mountain States chapter, which covers Colorado, Idaho, Montana, Utah, Wyoming, all the great places to go, I guess, skiing or fishing. Schneider has been working with architects, engineers, and building professionals for nearly a few decades. He's a regular contributor to several national and regional industry publications, including Retrofit Home, Accent, and Colorado Design and Construction. He's also lead AP and is passionate about efficient, sustainable design. Well, Jim, thanks for coming on. I appreciate you joining us. Jealous about the region you get to be in. That's a pretty cool area to kind of have to work around.
It is. I love it out here, and thanks for having me on the show.
Well, fantastic. So PCI. So tell me, what exactly is PCI, and how did you land at the Mountain States chapter?
Great question. So PCI is the Precast Prestressed Concrete Institute. So it's a little bit of a cheat in that there's 2 P's there, but there's like a slash in between. So it's Precast Prestressed Concrete.
All about efficiency, man. One letter, 2.
That's right. You know, saying PPCI just doesn't, it sounds a little funny. So PCI, but yeah, that is a national organization based in Chicago. Been around for like, I think about 70 years. But basically the national PCI is a bit, they certify precast, pre-stressed concrete plants around the country, serve as a big body of knowledge in precast, pre-stressed concrete. And then we have these chapters and regional chapters around the country that can do a little bit more on the ground work with design professionals, engineers, things like that to help get our product specified. So, as you mentioned, I cover these states in the Mountain States. I'm based in Colorado. But our precasters cover the area around here, and basically we do a lot of work. There's a big segment of our industry that does work in transportation, so we do an awful lot of like bridge girders and things like that for various departments of transportation around the country. But then we do a lot of commercial construction work on things. Parking structures are a very common application for precast pre-stressed concrete, but also things like offices, or I think it's a great application for schools, institutional, lots of different mixed use projects, things like that.
Yeah. So when you're LEED certified, but when you think concrete, it's not. Sometimes you think, okay, well, cement in general, and the process is not one of the most environmentally friendly ones always. Mm-hmm. But precast concrete, definitely a sustainable and efficient construction type, but where does that kind of marry up?
That's that's an area that I've, certainly I do a lot of speaking and content development on because I'm interested in it and have been. I'll say quickly that you asked how I wound up at the Mountain States region. I actually used to work at the national PCI back in like the mid 2000s and became familiar with the industry, and then came into this chapter in 2019. But back in, I think 2006 or 7, we were, really starting sustainability initiatives within the industry, and those are continuing. Precast, first of all, it's plant produced, so it's like a modular construction type, and so it's a very efficient use of materials. That's one of the reasons, we think it's a sustainable solution. And certainly we all do know that, yes, concrete has an impact where it comes to cement, energy, transportation, things like that. But when you think about something like, a precast concrete structure can last for 100 years. I mean, you stretch its impact out over a long period of time and look at it from a life cycle perspective, it does start to, it basically has a big upfront impact, and then it can provide a lot of durability, resilience, energy efficiency, things like that over time. And that, in addition to that, we're also, as an industry, and this goes throughout the concrete industry, not just precast, but we're certainly working to find ways to reduce the use of cement or find supplementary cementitious materials we can use that are less impactful from a carbon standpoint. And I actually just finished, I did a webinar a couple weeks ago with someone from NRMCA, the National Ready Mix Association, and we were talking about some of the innovations that are happening in the space with concrete, different types of cements and different types of carbon capture technologies, things like that, that can help us reduce the impact of the material over time.
So when you look at things like, you can't talk construction right now and not talk about two things: labor shortage and material pricing.
Correct.
With the labor shortage, I mean, when you're working with precast components and stuff like that, obviously you've got a plant, you're making it. But I would think, especially in like an office building, the exterior of an office building or a school or something, there's substantial savings as far as time on site for labor, I would think.
Absolutely. I mean, where the question comes in, it's kind of always dependent on a local market and what a precaster's schedule is. But the thing is like once you're in line with the project and you're doing it, it happens really fast. And in fact, we see projects all the time switch to precast from other materials because you can save months off a project schedule, because it is minimal, crew on the site. It's like a crane and minimal crew. It just goes up very fast, and closes the building more quickly, lets you get other trades involved. So speed of construction is definitely an advantage of the material just based on how it's put together.
Yeah, and time is money. I mean, without us,
Right.
Time is more money than money is, it seems.
Yeah, it's true. And especially a few years ago, we were seeing that, quite a bit where, it's like the timing is everything, and, people will, pay what they're going to pay, but now it's maybe balancing out a little, but I still find that generally we're very competitive in cost, but even if sometimes it might be a few extra dollars, if you look at the big picture, you're getting that back in the time you save, the quickly you're able to occupy your building.
So what is it like when you think about the competitors of it? I mean, I don't know that people always understand that. I would assume that your biggest competitor has got to be either steel or most likely wood.
Yeah, those are big ones. And even, cast in place concrete also, depending on, for example, we do a lot of parking structures, but so, a lot of them are cast in place too. And there are certain markets where you have contractors where it's kind of better for their bottom line to self-perform some of that stuff, so they do it in cast in place. But, precast is a very efficient, durable material for parking structures. So you'll have that conversation. But then, you're talking about office or different types of buildings like that. Steel is certainly a big competitor for us. And wood has become, as we've seen more developments and things like, like cross-laminated timber and things like this, where they're starting to be able to build higher. Wood has become more of a competitor for us in some of the spaces that we're in. However, we still think that precast has an advantage in terms of, durability, fire safety, all that too. But they're starting to knock on some more of the markets that we serve a little bit more with wood now. Yeah.
So as the technology is improving, pre-stressed and stuff like that, is some amazing things that they can do. I mean, I'm seeing pre-stressed members go in curved and finish out straight. I mean, these are amazing things. People don't think about bendable concrete, but, but when you, what are the other the things that, is there recent innovations at precast for man, I never would have thought they would start doing this in precast?
I think aesthetically, I'm always kind of blown away with some of the different innovations. We're doing some 3D printed forms now and different types of, some innovative form liners. And even there's a technology out of Europe called graphic concrete, which is really cool. You put it's like a retarder that you put down in the form. And when you pour the precast over it and it cures and you do a power wash on it the next day, it leaves behind whatever digital image that you've come up with. Like, either it can be just patterns or something that they have off the shelf, or it can be like an actual image or something that you supply digitally. So and it's actually not like crippling from a cost perspective. You can do some really interesting things with it. So we're seeing some applications of that come up now that are pretty cool. I think another thing for us is, I think back to when I started in the industry, almost 20 years ago. And, we do a lot of work with thin brick, where it's basically like mimics masonry with a precast wall. So you get the time and efficiency and all that stuff of precast, but it looks like brick. But the rub on it in the old days was like, well, it's a little too perfect looking, or the color isn't quite right. It's like, it looks kind of like brick. I'm really amazed by how far we've come in that, where you have form liners now that are actually like a little off level just to look like it's a little, and they'd have a tumbled brick product, or they beat it up, so it looks distressed, and you can go and do projects where you're matching existing masonry on a campus, or in a city or something that's got old masonry. We've come a long way in being able to more accurately mimic traditional masonry with thin brick, which is pretty cool.
So is PCI all plant-based production? I mean, if you're just tilt up and fall into that thing,
right. It does not. It is all plant produced. So basically, like, PCI certified producers. Yeah, they have a physical plant facility. They have to live by, it's a very strict certification program, along with showing all the quality control methods and all that stuff. They get 2 unannounced audits each year, where these guys just come in and like ninja, ropes in the middle of the night and check everything out to make sure everything looks good. And yeah, we even just about 2 years ago, we kind of upped the game on our architectural certification program, where now we have like an A, B, C, and D level certification. All of it really high quality, but like an A certified plant is somebody who can do like these super complex, tight tolerances for high-end office, corporate headquarters kind of thing, versus maybe a warehouse. It doesn't have to be quite as tight in tolerance and things like that.
So when you're looking at precast and thinking, okay, I get where they can use it, what's the place where you say you just can't use precast here for this?
It's not great for anything that's like, obviously like single family residential. I mean, where precast is advantageous is where you can get economy of repetition, basically. Like we see some great case studies. This is why I think it's good for schools or offices or things where you can still have like a really good aesthetic look, but have a type of repeatability in the form where you can reuse your form multiple times and get multiple pours out of it and kind of get economy out of that. So it is more suited for that reason to things like commercial construction. It's not good for small jobs, like where it's like a panel or two. It just ends up being too expensive. But yeah, anything where you have repeatability, you can usually do pretty well with it. And also, I would say, when we're thinking about something like schools, for example, I think being a good market for us, it's because it is an investment in like long-term operation. Like if you're talking, sometimes you'll have developers who just want to like throw something up and run away from it and not worry about how it performs over time. Precast does have a long-term operating advantage in terms of like with insulated wall panels, we get excellent energy efficiency, durability, things like that. So it can last a long time, perform at a high level. So, and it's, allows you flexibility for those types of projects.
And a secure facility too. I mean, a precast solid building.
It is. And we see it. I mean, it's used commonly in FEMA rated storm shelters around the country, places that have to deal with tornadoes, hurricanes, things like that. We have several different techniques for seismic design. That's something we deal with out in my part of the country, Utah and other states where we have to design for seismic. It's actually really good for that as well.
Yeah, which you wouldn't think, concrete typically good. Again, you're not looking for a flexible building when you think concrete, but
right.
Well, connections, yes.
That's what's fascinating about it. It's all the connections. It basically gives you this like combination of strength and flexibility when designed in the proper way. But we've also seen it used for government facilities, military, because it's good for blast resistance too. It's just a very strong material.
Absolutely. No. So when you're doing it, I mean, you're, this isn't just run of the mill ready mix concrete all the time. What's going on? I mean, these are high performance mixed designs. Low water cement ratios, I would assume, and I don't know how heavy on admixtures they are, but I'm sure depends on the application.
Oh yeah, it definitely depends on the application, but certainly we do that. Yeah, but it is very tightly controlled. I mean, that's kind of the whole idea of the plant process and the certification and everything. We have some pretty sophisticated mixed designs, and the way all this is done is tightly monitored. So you get a very high quality product, which is why if you're going to be doing precast pre-stressed concrete, you should be looking out for a PCI certified precaster, because they are following the guidelines that the industry has established for decades. And it's a really, like, the institute itself, I go to all their national meetings and committees and all that stuff, and it's just a really, like, passionate, driven, super smart group of people who are constantly innovating, constantly working on new things.
And precast plants don't show up in my Google search often, so I'm assuming there must be non-certified plants as well. So
there are, yeah, certainly, and it depends on what part of the country. Like just for out east, there's a ton of PCI and probably non-PCI certified precasters. In my neck of the woods, we've got a few in each state, essentially in my chapter, that do the work, but they're not as we're not as densely populated with precasters here as maybe other parts of the country. So it kind of depends. But no matter where you are, there's somebody in range.
Nice. Good deal. And do you also have to think about access? I mean, like, if you're in a tight city area, you got to be able to swing these components in place.
Correct. And then actually that is another advantage of precast, because of its nature of kind of coming to the site for on-time assembly. We actually do a lot of work in really tight construction sites. It's very efficient for job site.
I guess that does make sense. I was thinking of the other direction of what worker is. You're bringing one component at a time.
Yeah, there's no real staging, and you basically have a crane that's in the footprint of the building usually and can assemble things and then move out. So it's we have some time-lapse videos that are pretty cool, but it's amazing how fast and efficiently the product goes up once once you have the panels. It's like, boom, boom, goes up fast.
Yeah, I like to see it. Yeah, I'd have to get a link.
I'll send you some. Yeah,
I'm sure that is enjoyable to watch.
Yeah, it is. And you also can see in a lot of these, especially, this varies too in different parts of the country, but here, weather is an issue. It's like, and precast does go up in pretty much all weather conditions because the pieces are built off site. We can erect it in just about any kind of weather. In fact, one really cool project that one of my producers did recently is the visitor center on top of Pikes Peak, which is, talk about an unfriendly environment. I mean, they actually had to schedule workers to only be up there for, I want to say 5 hours a day because the elevation is so high. And they had to pass physical stress tests and stuff like that to even be able to work up there. Then they had to get the pieces up there and assemble it. And it's also a living building challenge rated building, which to my knowledge is about the toughest green building certification there is.
And as a side note, if you're looking to watch good videos, watch some of the races where they race going up to Pikes Peak. Drove back. That's the first time I've ever gotten scared driving a road. And then you get out up there and you feel drunk because of the oxygen deprivation. You're like, I'm getting down. I'm not safe to drive now.
No kidding. Yeah, that's kooky stuff. So yeah, it's pretty wild. So we build anywhere. We haven't gotten our first project into the Antarctic yet, but we'll work.
That's right. Everest next. We're going to visit.
Yeah, right. Everest. Absolutely. Yeah, I've been talking to some Sherpas. We'll get it worked. Yeah.
They're excited about sticking those components up.
Yeah. I don't know how much precast we can carry by donkey or whatever up there.
Yeah, get it back up there. Like, I'm sure it'll be bad. It's like, brick at a time.
Right.
Oh my goodness. Well, man, this has been fantastic, and I really look forward to kind of. And now I'm, you may be a nerd if you've watched a precast time lapse while sitting at home.
Yeah,
I'm looking forward to seeing that, and I really appreciate you taking time to meet with us, kind of learn more about what's going on in your area and in concrete in general. I mean, it's around everything that we do.
It is.
No, I appreciate it.
It's the world's most commonly used, material, and it's important that we do it well and do it right. And I think as an industry, we're doing some cool things.
Absolutely. No, I love it. Thank you. I appreciate your time.
Thank you, Chad.
Hey, take it easy.
Thanks for listening to This is Concrete. We look forward to you joining us next time. Be sure to click subscribe to get future episodes.